contribution. He will be speaking how actually India is taking steps ahead. It's a thought-provoking talk which I have seen actually. And he will also speak about like how you can apply for some UN-based jobs. Like he was mentioning that most of the time Indians do not actually try to apply for these UN jobs, and most of the time like we are not getting a good representation on the world conference, world roundtable conferences. So these are the few things. Before I actually invite the guest, I would like to give an introduction about the guest as such and his distinguished capabilities, what he has performed over in years of around 42 years he have been working in ocean related aspects. So please give him a round of applause by so that we can invite him. So, Dr. R. Venkatesan, having a 42 years of experience in ocean science and technology, and he has served in premier institutions like National Institute of Ocean Technology and National Institute of Oceanography. One is in Chennai and the other one is in Goa. And he has also worked with UNESCO, IOC, as well as he has worked with UNEP regional seas and associated with UN bodies like World Meteorological Organization. Is one of the active members actually in World Meteorological Organizations, which he represents us from India. And he is also the vice chair of SGOIS and many committees in the World Meteorological Organization, Geneva. And he is a vice chair for Asian continent. He is also part of DBCP and executive committee member of international working groups such as Ocean Sites. There's something called DOOS, which is basically again Ocean Observation Systems based organization. Then we have OASIS, OBPS, Smart Cable, and many more. He also teaches ocean policy at IIT. He also deals about polar law at Dr. Ambedkar Law University. He is also a professor of practice in Anna University. He is a retired scientist from National Institute of Technology, and after that he is doing his service. He is a sort of a terrific taskmaster. I have worked with him actually during my initial career, and things get very smoothly done even though we see a lot of bureaucracy. Also, over the past few decades, he has received many awards. He's an adjunct professor at University of Massachusetts, Dartmouth, USA. He's a Fulbright Fellow and is associated with US IEF. And it is a part of US Embassy. He is currently actually a member of this particular organization. And over the 2 decades of his service, he was honored with 20 prestigious awards like Lockheed Martin Award and a joint recognition by UNESCO, IOC, and WMO for his contribution both outside India as well as for the national geoscience activities which he has done within the country. He has also received the National Geoscience Award from the Honorable President of India, a national award from Ministry of Earth Sciences, Tamil Nadu State Scientist Award, MTS Fellow. He is one of the active members of Marine Technological Society in the whole world actually. And he has earned his PhD from IISc Bangalore. He has completed courses on like marine pollution, maritime law and international business management, which India is still nascent in making steps towards it actually. He is one of the active members to bring ocean policy to India, where the Western countries are doing a better job there. He visited Arctic and designed and installed one of the moorings actually. It's the first underwater observatory at Arctic. He has traveled around 40 countries and he has been collecting data from different sort of seas, basically from not only from Indian Ocean, Arabian Sea or Bay of Bengal. He has done these works in different oceans in the world. Also, he is sort of collaborating with many universities in USA and the Europe. So he has deployed one of the important aspects where we have seen that tsunami has occurred in 2004, and we have seen that India had to put a lot of efforts to bring in tsunami awareness actually. He is one of the active members in bringing those observations to real time actually. Previously India was nowhere. Now we can get the real time updates within 15 minutes to half an hour. So that is what he has actually done as a part of ocean observation systems. I think it is really a big achievement. You should give him a big round of applause. And he has obviously published 190 plus research articles and conducted student competitions, Guinness World Record with school students, and is a guest editor to IoT Journal of Computer Society. So he'll be sharing us some insights on emerging technologies to tackle climate change, and specifically he'll be focusing on oceans. So which promises to be an enlightening talk. So let's again give him a big round of applause. Sir, please.
Is it okay? That's good. And the slide. Oh, thank you. Sure. Good evening to everyone. At the outset, I thank the director for inviting me, and the Dean, Dr. Aniruddha, and Dr. Amit Shukla for making these efforts, and also to Dr. Jagdish, who has been persuading me to come over here. It's a great honor for me to come to this institute. I'm really happy to see a very wonderful facility here, and terrain like this to bring out a facility, somebody to visualize. I really appreciate the architect, whoever it involved, and the first director who was here. I visited many places, but bringing out such an institute, such a campus requires a dedication and a teamwork. Hats off to all those people, and today I'm here to talk to you all. And you can get a question in your mind that why out of all somebody is talking to you on ocean. Yes, I'm trying to bring an awareness to you first. We are all part of the earth system, and how ocean is linked to us and day to day what we are living. I'll be talking about my experience more than 15 years with the United Nations organization. I always, like Dr. Jagdish said, why not many Indians are not there. There could be opportunity for you to think in a different way. Next, about my own experience, the team, what we National Ocean Technology we have done and collecting a real-time data, what challenges involved, and an experience can be useful for you in your own way. And finally, sort of opportunities, what is available there. Now, this part of a picture of Earth you would have never seen. This is a Pacific side of Earth. Really, you can see that 70% of the Earth is covered by ocean. And it's how appropriate to call this planet Earth, could have been an oceanus. This is what the clerk said. This is a recent picture from another geostationary satellite, as clearly giving a picture how the Earth looks like that, very close, 25,000 kilometers away. Now, coming back to the ocean, another important thing is that we have our trade, 90% of the trade comes from the ocean. And all over the world there is a major focus on blue economy. That is converting the opportunity and bringing all the industries together. India's Honorable Prime Minister has announced our own blue economy policy. We have brought in various regulations and support to the industry to work in the direction. The interesting part is sustainable blue economy. That's what is the discussion is happening, where engineers need to play a role and bring out technology and work in this regard. And just to give you one slide, I can speak in length about this blue economy, just to appreciate you. Use it in a high mountain, and you have a deep, far away from us. We have our own, we have exclusive economic zone where the sovereign rights of the country is there. We call about 200 nautical miles. Far away from the ocean, in the open ocean we call it, where India has got our own exclusive rights, because there are places there, polymetallic nodule, there are ores like manganese, cobalt and nickel, they are strewn around on the seabed. They're about 5 kilometer depth. So this is what is our interest, similar like that to polymetallic sulfides. So these require a more effort, lot many technological requirement as well as the environmental regulation. These are all required that need to be looked into it, because we all use stainless steel. The current scenario of nickel and cobalt may get depleted 75 to 100 years. Then we have to look for these opportunities. That is what is a global interest towards that. Again, I thought what could be interest to you? Climate change and cryosphere plays a major role. India, we have got a lot of interest in this direction. We have our presence. We are part of Arctic Council, and also we are part of Antarctic Treaty. So you are linked to that, and the third pole we call it is Himalayas. We are part of this system here. And India, we are showing a lot of effort. There are very close to you, there is an observatory where we are collecting data. Now we know very well that more than 1.6 lakh glaciers are there. I myself have seen many glaciers in Europe and US and Arctic. These glaciers are really giving us, they are warning to us, yes, they are retreating, and the global temperature is increasing, and you are part of a component of the system of Himalayas. The confronting climate change, how to save this. This all happened in 50, 60 years. Not, if you look at the data, we never faced such an issue earlier. So herein, how best we all can work together and work in this direction. So what are the challenges? What are the way forward? What I thought few points could be for the Himalayan region. It is globally one of the consistently warming region among all the glaciers, and we can see the effect, and also we can see the shrinkage of melting glaciers, and also there are increased risks and hazards. We have seen very often the floods, and so these things are looking in a different way. Very recently you also having a geospatial maps. They are talking about how forecast could be given in a much better way. But for all these things we need to collect data. There only the information is required to run the model, give a forewarn to the people. So herein again we have a role to play. So the knowledge generation and understanding the possible impacts and the resilience part of it, these need to be done. So there is a collective effort of different disciplines, including social scientists, need to work to save this earth and to work in a much better way. Again, another picture I thought which can give you can appreciate that even though you are far away, the monsoon is specific to our region. The monsoon depends on the wind pattern that comes from far away from the ocean. Now, not only us in this region in Indian Ocean, among all the other three oceans, Indian Ocean is the northern part is landlocked. That is what this monsoonal winds and change in the temperature is increasing, giving us this. So the food, water, energy and economy, they are all, and security, they are all linked to that. Again, you have a role to play. And again, these are all some issues I can talk in length about. The marine heat wave, the increased precipitation. You have a large amount of rainfall in a short duration, even though average rainfall remains the same. These are all linked to the Indian Ocean getting warmer by 0.5 degree. You would appreciate that Indian Ocean is so big, about 3,000 meter depth average, it maximum about 5,500. But that much amount of water column, many of you would be working on fluid mechanics. You can see the energy required. That is what is the challenge we are facing. That is what again ocean is linked to that. There is a bigger topic about air-sea interaction. We are working with the team with collaboration. So still it is not clearly understood. We need to go in that direction. Again, I thought this particular slide will make you to appreciate how we were good 1,000 years ago. We had a Chola kingdom and they had sailed out. And if you look at it, how in those days, today we have the technology with the sailboat, how they were able to sail. We talk about monsoon, but they were having the capability, they were sailing it. There is an evidence which archaeologists have brought out, like we have a float festival that is happening in a particular time, where in those days these unmarried soldiers used to return in the boat, and the unmarried girls would be waiting for them. This festival is common in Indonesia, in Malaysia, in Cambodia and other part of it. So this is what is the linkage. We had our own capability, we had many other technologies like compass, we have Astro. These are all developed by us in those days. Without that, they would not have ventured into that, they would not have sailed. We had our own navy. So this is to show you how we were good enough to understand about the ocean around us. Next is about UN bodies, as it was told. We can also look for a UN jobs for your career opportunity. Even recently also for IT professional there are opportunity. Wherever I go there, even in UNEP, I was there. We used to look for Indians who are supposed to be working there. There is also a quota system. Unfortunately, I did not find many IITians over there. This is what in my class in IIT Madras, when I used to teach ocean policy, I used to emphasize that. So this opportunity can be thought of. The World Meteorological Organization is the one which has been working last 70 years, and they have been working on atmosphere. The Earth as a whole system, it consists of atmosphere, ocean, cryo, and hydro, and also space. And all this have to be looked into that at the Earth system as a whole, as a one. Then only your model prediction would be much better. When you talk about the weather, it is complex. When you talk about climate, it's much, much more. Herein I was involved, nominated by the Government of India. 4 years I was a vice chair of a committee, where we are trying to bring out how the ocean component can be brought in there, how the ocean data can be bridged together. Because the meteorologists have been one of the most structured in the UN system, have the countries are directly involved into that, and the WMO Congress is treated very well, and all the decisions taken by that, the policy level, it gets into the country level. But in the ocean component, it's much, much more complex. It's not defined. It's not to be one particular ministry. So these are all the challenges. And how do you make the countries to collect? We are much better. I'm proud to say that our data collection, our predictions are much better. And there is a globally agreed the data collection methodology called GBON, Global Basic Observing Network, that has been brought in. Countries like in Africa, there are complete data blank. And during the COVID time, it has got much, much more, the challenges were faced. That's the reason there is a possibility of getting funds. $500 million has been mobilized. And there were 41 countries, particularly small island development states we call SIDS. They are all much affected. They are part of that. So this is the current scenario globally. Again, engineers are involved. I was part of another subcommittee. We were discussing about 2030, 2040 in futuristic way. The computing facility, what you got on 1.5 terabytes, that be sufficient, or they want a storage. So we talked to the modelers group. One is about speed, another about the storage and collecting data. Currently, we are not using much data sets from the space, mainly because of the operational constraint. This discussion is going on. The requirements have been brought into the industry, so that in future, when we talk about more amount of data sets, we have the capability to analyze. This is about ocean governance, where I was involved. I was selected for the Asia Pacific for 41 countries in the steering committee for 2 terms. Subsequently, I was a chairman of Goose Regional Alliances, about 13 regions globally. When India was heading that, I was made as a chair. Subsequently, after 2 years, I handed over to US now. Wherein we talk about we cannot manage unless we don't measure about that. This is common to everyone. So the ocean is, even though 70% discovered, is sparsely managed, sparsely data sets are collected. So we are trying to see how best we can bring the policy together, how to share the data, another biggest challenge. Within the EEZ, exclusive economic zone, because of various strategic reasons, the data sets are not shared. So this is a current scenario of various countries. More than 80 plus countries are one way or other, a small way, they are involved in data collection. Some of them are sharing, some of them are not sharing. But it may look crowded, but it's not the case. It's not real time, some of them. There are various tools used, but not all of them are depicted here. But there is a positive sign to say that yes, countries are involved. And now we are discussing in a broader level, how do you appreciate one country doing it, how others are not doing. So this is on the broader level. This was work which, after my retirement, I was appointed as a consultant, independently employed at UNESCO. My job was to involve 150 countries. Out of that, 10 countries are landlocked, 140 coastal nations, to bring a national focal point. I'm talking about the complexity involved. Any job has got, here is much more complex. Connecting these countries, bringing them, because in ocean, it could be linked to meteorology, it could be environment, it could be fisheries. Every country it varies. So I had an opportunity to interact about, I was successful in bringing 77 countries together, and I arranged an online meeting over 90 plus countries. Then we have to understand the complexity in each country, how it is involved. Funding, India is much better. Our government is providing sustained funding for such work. It's not the case in many other countries. So for Europe, about 25 countries, I was, last September I was in UNESCO. I organized a meeting with them and interacted. Why all this thing is that share the responsibilities, share the challenges, and whatever you face, communicate with others. So this is what one work I could do. When we talk about all these things, you as an engineer would like to know what type of parameters need to be collected. You have this Earth climate variable, which has been broadly accepted. IPCC report talks about ECV. From that, we evolved the Earth ocean variable, EOVs we call it, physical, chemical and biological parameters. This has been standardized. Any publication need to follow that. This is a one important output very recent days. I was also part of that. Next is, how do you collect the data, and where we stand and how do you proceed that. Collecting data in the ocean, the Eulerian or Lagrangian, the two methods we collect. One is the instrument is fixed, or the data collection system is fixed. Another one, it is moving along with the water column. This is the way we do it. And the challenge for us is, in the way back about 30-40 years ago, the ships were used for data collection, and it was realized that the ocean dynamics so much, it doesn't wait for the ship to come over there. Then the robotics tools are brought in. Second World War brought more interest towards studying about underwater acoustics. Then comes the equipment like echo sounder and side scan sonar, sub-bottom profiler. To understand about seabed, the more interest were shown. So herein we use, either you have a fixed system where the instrument is fixed, different suite of sensors are attached to that, they collect data and transmit in real-time mode. The challenge for is, underwater communication is only acoustic, above water communication is through satellite or electromagnetic radiation. So it's not, the satellite doesn't penetrate more than 75 centimeter, close to 1 meter, in turbid water much less. So keeping this in mind, these tools have been designed, they have been functioning and providing data sets. These are all some tools, and the locations where we go are far away. We sail out and come back after a month. So we have to plan from caught up into container, all the equipment need to be collected and sail out. This is what different type of tools. One is recent development is on a glider, which works on a buoyancy principle. The buoyancy variation makes it to positive and negative buoyancy. No energy is used for making it to dive down. However, for transmission alone, the lithium battery sets are used. So this is one of the last 15 years, this particular tool, we specially call this as a underwater robotics called Argo floats. 50 grams variation is making it to dive down to 2000 meter water depth. It remains and it pops up to the surface and collect data, and it works for about 3 to 4 years. It is designed in such a way. Today, many of our understanding, publication related to El Nino, La Nina, in relation to ocean, that has come from this. I'm glad to say that one of the school teachers from New Zealand, she picked up, and there are many tools available, models available, products available. She started teaching this in school level. I'm very glad I'm getting connected to such school teachers who are showing interest, educating the children. I worked with some of them, they are much more faster than us to understand about. They read a lot. Even when they conducted a competition, they came out with a nice video tools, and even one of the essay competition, we made 6th standard student from Air Force School in Delhi and on Chennai School to publish in an MTS journal, which has got a good impact factor. This is the level of motivation we can bring. So that teacher has done a good work. So coming back to this data collection, these data sets are freely available. Even in India, INCOIS is the Indian National Center for Ocean Family Services, they have it. For a fun sake, you can see what is the temperature at 1000 meter, 2000 meter, whether it varies. You can look at it in a different perspective. This is a system which is moved in a particular location with an anchor. This was designed by us, our own team. Initially, we were importing it. Last 25 years, India has been collecting data. The initial funding was from the Norwegian agency. Now we are not depending on anybody. I'm glad to say that this is functioning. Every year we have to go. The system has to work for corrosion, biofouling, cyclones, and many other challenges we face in the ocean, but still they collect it. It has got a mast. We normally collect at 3 meter level, that's a datum, because when you extrapolate it, it's 10 meters, a global standard. And it's got about 100 parameters we collect. Transmission is once in 3 hours. Subsurface, what you see at the bottom is continuous data, temperature and conductivity data. And making this to functional transmission is really a challenge, and we incorporate a lot of redundancy, and two-way communication is possible. Here in the challenge, what India faced compared to others is, we used Inmarsat, which is geostationary satellite, was consuming about 10 times more power than Iridium. Globally, everyone was using Iridium satellite, which is a LEO satellite, was consuming 1/10 of that. However, thanks to the government, I had an opportunity to visit to the Ministry of Home Affairs and spoke to the Joint Secretary, because there are also other strategic reasons. I could convince them that we want only for data, not for phone, and also all our data sets are encrypted in the platform itself. That word of encrypted, what I said, convinced them. I'm glad to say that the approval has come. We are changing all our system from Inmarsat to Iridium. This is a level, when you look at it, you get a support from all aspects. Seeing that Navy also wanted it and they have provided that. Coming back to this network, this is globally, US is playing a major role, and India and US, we have joined together. We are collecting data. You know very well that the major amount of heat energy is falling on the earth, and the polar region it is less. All amount of the atmospheric circulation or ocean circulation is related to that. So looking that in mind, the NOAA has deployed the system, and the understanding between India and US is that they come with the equipment, we provide the ship. In India, we are equipped with the ship, especially designed for such application. They can sail it for 40-45 days in the open ocean. So in this process, we learned a lot. Our system got improvised. I'm glad to say that 2 years ago when I was in service, we jointly launched a data portal outside the EEZ. We are sharing the data. India and US, we are sharing the data for global community. This is our data center, which was developed by us. I'm proud to say that this is functioning. Even during the COVID time, we had people monitoring over there. This is providing wonderful information, and all the data sets are archived and protected, because approximately, if you calculate, one data point may cost you about 200 to 250 rupees, the amount of cost involved considering the ship time. So there is a lot amount of interest being shown in safeguarding these data sets. This is to show you what importance. Why do we collect that? The understanding about our monsoon has changed a lot, because now we know very well the subsurface measurement and surface measurements of material or atmospheric measurements, and clearly tell far away from the open ocean. Before the monsoon normally comes in June first week in Kerala, we were able to predict that. And subsurface measurements, we were able to clearly correlate. A number of publications have come. I cannot say we have succeeded. We have started understanding. More and more interest is required. Why? Because I will take a minute to say that we have a specific, one till I said the monsoon, and the coastal, East India coastal current, we call it, more specific in our waters. The current direction changes. Because these type of specific conditions we have got, only we have to study, not others can study, because within the EEZ that others cannot study. Next important point is we have Arabian Sea and Bay of Bengal, west and eastern side. The Arabian Sea has got less amount of river flow, whereas Bay of Bengal has got Ganges, Brahmaputra. These waters bring large amount of fresh water. That is what is a challenge for us. We call stratification. You have got the cyclone formation, everything mainly because of the stratification Bay of Bengal. This current work, what we have done with the Indo-US collaboration, American ship came here, we sailed out, we trained a lot of students, some of them are working in US. That is what is a contribution. Next to Amazon, the Bay of Bengal is a region where we have got large amount of freshwater influx. So this is to show you that in 2020, May 12th, we were all locked at home and we were not moving out. This cyclone was cutting at all. We were monitoring it 6 days before its formation, and on 20th May it landed in Calcutta. Thanks to Indian Meteorology Department, the prediction was perfect. And for running the model, there are 6 parameters. There are many more to make it in a simpler way. 3 come from the atmosphere, 3 come from the ocean. So we were providing these ocean parameters. Thanks to our team, they remained and they helped us. Coming back to the super cyclone, which happened 20 years ago, the death toll was much less than a single digit. Who ventured out, thanks to the administration, thanks to the complete network what you got. This is well appreciated by the World Meteorological Organization, and the Indian Meteorology Departments appreciate that the letter was provided by them to us. And we not only share the data to us, we are providing for the whole region as a whole. This is what on satisfaction, technology reaching the society. That is what we are all here. That is what the contribution we need to do that. This is one classic case. This is a rare picture taken by our own team in 2004 tsunami. On that fateful day, I was heading in biology group. I had an opportunity to head different groups. My own team was there and having a tea in the tea stop in Hat Bay in Andaman. Then somebody told me that there is a water attraction is taking place, jump into the water. They cut the mooring rope. Mooring rope is the one which is tied into the boat. The boat sailed out. Nobody knew that tsunami. Later on, they came to know that the people who served the day, they got washed away. It's a fateful day. Unfortunate thing, this tsunami till that time we were thinking ocean is for recreation and for tourism. The fear of ocean came into the picture. Subsequently, Government of India established a tsunami early warning center. I am proud to say that with a lot of iteration, we established our own tsunami early warning center. We established the system. We had interaction with the different discipline. Next to US, you can see that about 13 countries have got such type of warning system. It means we deploy a mooring buoys, and India is the one we call Sagar Bhumi. Glad that we got a patent, we deployed it. Why I am emphasizing that, many of you may not be aware, we are very poor in communicating that. But however, this is an interest to show that to develop such a system is very complex, because the tsunami is nothing but it's something like earthquake based. What we get is you have three different waves: wind driven waves and tidal waves, and the tsunami waves are long waves. The pressure is felt. There's a bottom tube pressure gauge with a system which is made by only one company called Parascientific, and this instrument called bottom pressure recorder is tuned to measure every 15 seconds one data sets, the water column. If the variation is more than 3 centimeters, it gives an alarm warning. So this we understood. Initially we were importing from UK, subsequently we developed. And the underwater communication is acoustic, above water is, as I said earlier. So the communication is such that from the seabed, which is about 2,000 kilometers away at 4,000 meter water depth, has to come to the desk in 5 minutes. This is what Home Affairs Ministry or the government wants it. We succeeded. We are providing such information to us. Thanks to the whole team, it took a lot of iterative process to select the software and hardware, everything together. Another challenging that we decided to have our own underwater Arctic observatory in Arctic in Svalbard. I had an opportunity to lead the team, and we designed in a short notice. We deployed that. It's more than 10 years now. Every year we go and retrieve and repair and refurbish and redeploy back. If this region gets frozen in September, I'm glad to say that we have more than 30 lakh data points, physical, biological, chemical. I had to have one paper published in Nature. And we have many more things have come, many students have worked on it. This is a small contribution. Again, I'm talking about different thinking. The foreign minister of Norway said how a tropical country can come and establish a system and work on it. We learned through experience, and it's succeeded, and it's working very well. And this is a picture of deployment. This has to happen in 20 minutes. In any of the system, once you fail, once it make a mistake, you can go back only 1 year. You lose the data for a year. Leaving aside all these things, I thought some of you may be working on materials. I thought I will show you some interesting picture about Titanic shipwreck, which has crossed more than 100 years lying on the seabed. People would have never imagined that microbes can eat away the steel material. After COVID, we know the microbes, what it can do in our life. Henry Taman, good friend from Canada, she published this work of the Titanic shipwreck is eaten away by microbes. We had the same issue when the bottom pressure record of tsunami early warning was deployed. My team, they always think that I try to do something. They preserve that. There is a mucus substance on the equipment when we retrieved it from 3,300 meter water depth. We analyzed, we contacted microbiologists, and we also checked that could be from the extraction from the whales, but the whale doesn't dive down 800 meter water depth. That could be from underwater volcano. Close to that in Bay of Bengal we don't have. Then we proved that yes, this could be possible from this, and we published it. The challenge, one point noted here, is that this corroding material did not corrode the painted one, only the barren material, even 17.4 pH, one of the good corrosion resistant material got. So we conveyed this message and published a work that anything underwater, don't leave barren material and coat it. And this is some of the work like we have, our main work is operational. But in spite of that, we develop our own product thanks to the complete team. And, some of the product we already developed and transfer the technology to the industry. And we too have our own patents. We have underwater robots. All these things are applicable for aquatic condition. It doesn't mean that it's for the marine alone. And they have been successfully doing in many other activity. Now I thought, having seen all, what makes us to think about ocean? What's the difference between space? And the space is easily approachable. Ocean is not easily approachable for the common man who are far away in hinterland. But it fascinates us. One of the things where the fascination comes, many of you may be reading about, this is what interesting is about Arctic tern. Is a tiny bird. When I visited there, I was told to carry a stick because this Arctic tern comes and hits on your head. But this Arctic tern, I met some biologists working in Netherlands. They track this they try a tiny satellite tracking system, because the bird cannot carry the weight. It had a very tiny solar charging panel, and you can see the track. It takes about 4 months. On en route, it passes through water in Greenland, it reaches Antarctica and comes back. So this is being now discussed in a different way. In a sustainable engineering, they are talking, can this type of biomimicking, can it think in a different way? When animal can do, why can't we develop a system like that? This is something out of box thinking we can plan. This is a, I don't know whether it will run. This is, we also work on passive acoustic sensor data, and initially our team started working on collecting such information, having the mode buoy, and they provide that. This is about, this is from the whale and dolphin, different animal. Yeah, we have also analyzed and different frequency we have documented. In addition to that, next slide. Next, yeah, sorry. This is about vessel noise. The vessel noise gives the information how much amount of vessel traffic is there. This was published in during COVID time. Next. Yeah. So why I'm showing this is that, I can stop that. Why I'm showing is that here it's not the only oceanographer can do, only engineers need to do. We had our own challenges in analyzing the data, and I'm glad that a lot of youngsters have used, and we have many publications related to that. Then the strategic application Navy came forward to ask us, because there are also reasons to monitor some enemy submarine movement in that region. So we provided some data sets, we worked along with them to develop newer tools. So when you start working towards it, this is an interesting area currently being worked into that. Next is about underwater volcano. Like you have land-based volcano, there are volcanoes do exist underwater, and very recent study, we can see that picture. There is a group of there is a institute called Schmidt Institute. There they do a lot of work. They found the longest animal, and there is a group of octopus moving in a deep water. So, and also they found there is another interesting publication close to this, 4,000 meter black oxygen, they call it. Oxygen was monitored. So there is more and more interest towards looking these aspects. Now, last part of my lecture, what do we do? Coming back, all these things, we talk about climate change, we talk about sustainability. What, as an engineer, what challenges we are facing, how we can contribute to that. Some few points I thought the students can grasp from this. One is about plastics. I also worked on plastic. My first publication was in 2003, wherein marine debris in Great Nicobar we found, mainly because of the ocean current, the passing ships to the Malacca Strait, whatever they drop, it was coming to the Great Nicobar. Now there are a lot of work, enough publications have come. This is written in UNEP also. 80% of the marine debris or plastic come from the land-based, and 20% come from the passing ships. Out of that, about 1,600 rivers bring the marine plastic into the ocean. So there is a global focus, there is an interest, there is a big talk about that. However, there are tools need to be developed. There is one side about data collection and understanding, but once it comes to that, it remains forever. Even though it becomes tiny, it will remain there. How one can start cleaning? These are all some idea. One Dutch firm was brought in, where air bubble method they started using. There are also another method where is a Randmarine is one Dutch company. They started collecting underwater robot for such debris collection, and they also made this robot to have an interconnectivity. When the collection takes faster, that shows that there is more amount of debris there. This collects about 500 kg. Then another robot automatically senses that and comes and towards join with that. So such amount of intelligence is required to make this planet livable for our future generation. Next is on the shipping side. There are also automatic shipping is being developed. More engineers are involved, nothing to do with marine engineers. And the one ship is Mayflower. It is circumnavigating the world, and it has crossed 400 days. And herein you have to bring in brilliance and intelligence to that. Like you have a captain or a master sitting there, he understands the passing ships. But how do you bring that, all these variables, all the possible scenarios into that? That is being tried and attempted. Next is about electric ferry, completely electric, no pollution from that, because atmospheric pollution is a major challenge. Greenhouse gas emission is another important decision which World Meteorology Organization has taken. The countries have agreed to come. In particular, we don't have much data on ocean. So the greenhouse gas part can be removed. Then another one is the wind challenger. We know that the drag related to that. In spite of that, even very recently also another ship has been built with wind, like ancient days, and that's another newer thinking. So I didn't touch upon this particular topic, which US is showing a lot of interest. Even in Germany recently, in one of the meetings I found, how the carbon sequestration in the ocean can be enhanced. There are $1 billion project has been sanctioned towards that. And that work has been, one side there is the environment group is talking about that. Other side, engineers are working towards in this direction on this part on carbon related work. So these are all potential area. In general, what we can broadly divide in three parts, like we talk about how to bring not to have any waste. And again, I know that this particular work is being done. And we talk about sensors and sensing. That's another major challenge we have got. There are limitations. Even in underwater, the sensing part is much lower. There are more tools and material development is required. Finally, the new tool like artificial intelligence, how best it can be used and exploit that, the capability for betterment of mankind. So sustainability in engineering projects are being emphasized everywhere. So we need to work in this direction. So this is about plastic. We know very well the plastic is gone to the deep ocean. Even in Mariana Trench at 7,000 meter, 11,000 meter water depth, we have plastics, and that will remain forever. Honorable Prime Minister, he emphasized on controlling that. We as an individual need to take care whatever we do, either in hinterland through rivers or rain. Finally, it reaches the ocean, and that's a big challenge we have launched. Even in Arctic, which is no way connected, the circumpolar current as well as surface current from other part of the world, plastic has reached Arctic also. So these are all some area where we can start thinking. The monitoring on the air quality, again more tools and sensors are required. These are all some area which globally people are talking. Sustainable energy, ocean energy, yes, we know very well, wind energy, wave energy. Offshore wind energy is really picking up. India has got our own policy. Jakarta is one place where we have launched the system for data collection, wind profile data collection we need to do before the final project. One is in Rameshwaram, near Ramanathapuram. These two locations have been identified on offshore wind. OTEC, yes, we worked on it, Ocean Thermal Energy Conversion. I was a project leader to construct this plant. We had our own challenges in deploying that. Currently, this work will be taken up in Kavaratti in Lakshadweep Islands. So again, a smaller level like gradient of salinity. These are all something I'm sure that days to come there will be more potential for us to tap these resources. Climate modeling is one thing which engineers need to look at in a broader way, because long-term decadal data, how to run, how to make the better prediction in future. For you, close to that, I thought flood. Even in town, Chennai also, our Minister of Earth Sciences, we have brought the flood monitoring. So Earth system, the flood monitoring is really playing a major role. There are more hydrology components also involved into that. That need to be looked in a broader perspective. I'm also an independent director for the Tamil Nadu Water Resource Corporation, TNWRC, RRC. Recently I've been appointed. I know very well that like Tamil Nadu, you got Himachal Pradesh also, we have a rivers. One issue is related to pollution, another issue is related to desilting. And these are all the points. Next week we'll be having our board meeting, we'll be discussing that. Again, we are trying to see how best the technology can be brought in, how best the engineers, young engineers can be involved into that. In Tamil Nadu, I'll be discussing that. I'm sure that this area, definitely there will be more interest by the government of Himachal Pradesh. You can start thinking in this direction. So I thought few points, maybe some startup who have come, and I'm also in touch with them in the international meeting. This is one of the work, this guy called decoding of corals. Coral reefs are nothing but is an ecosystem. The Great Barrier Reef is the only one which could be seen from the spacecraft. And he was working in Google, particularly Google Map. He had a major role, Mr. Sergey. And this particular work is really bringing out the biological data and linking AI and bringing out a tool and product towards that. You can see his website, and that is really a newer thinking. I'm really fascinated because biologists talk by biologists on identification, and he leaves that and he talks about the deterioration part. But how to safeguard, how to bring a new tool, this is what is the ES brought out. Next is, I never could imagine that the corals can be made manually. This artificial coral reef somebody started developing in US, and I was in discussion with him. He finds that there is a potential market. He started supplying in Middle East. Even in vertical wall, he started developing this. So this is a newer thinking, newer idea. I thought out of box thinking is required. Maybe similar way you can think in the way play what you got. This is about smart cable. I am part of this joint task force. You know very well about 1 lakh kilometer length of submarine cable. Today what we are talking, internet is mainly because of the submarine cable. They have enhanced the level of data transmission much higher. However, Google owns about 16 cable, about $16 billion worth. And they announced that they've got a capability to identify the earthquake. And we started discussing, part of our team, somebody approached them, and the idea here is that they have got electrical to optical and optical to electrical. One is by Nokia. This system is standard and they always monitor that. It's calm and quiet underwater. But when there is a cyclone formation, because of the acoustic movement or the sound waves travels, they were able to pick up. Somebody from San Diego developed an algorithm for them and they gave it to them. And that is really an eye-opener for us to think in a different way. Currently, we are convincing. There is one project launched in Portugal where about $160 million worth of telecommunication cable will be fitted with sensors. We have brought 3 temperature sensors like a pressure, which is not having any strategic complication related to that. I am very glad to say that these engineers are telling underwater wet connection is not a problem. We were worried when you attach a sensor to that. Most expensive cable laying is much more expensive. Simple cost like the cable laid from Chennai to Andaman, about 400 crore it costed. So how do you maintain that? They said no problem, we will take care of that. That's the level of advancement has come in connectors. They are able to do that. If that is launched, there are a few more places in Pacific Islands. The team is working. This team comprises of industry and government like us, individuals working towards that. And I thought another interesting piece of information, how engineers are linked to law. I teach polar law, and we are also having a MOOC course with a professor from Law University. I also teach there, and I'm also visiting a professor there. So keeping this in mind, not even 1% of digital crime is convinced in the court of law. Then I understood when I was interacting with them, there are many engineering graduates who have joined, become lawyers. So we thought the 2 universities can come together, Anna University and Dr. Ambedkar Law University signed an MOU. And I'm glad to say that the Vice Chancellor announced that there will be an optional course of law in the sixth semester for the student to think if they want to opt towards that. I'm also trying to link with a professor from University of Florida, Florida State University, where they've established one of the most advanced laboratory. We thought both university can establish. We are working towards in the direction. Only I think IIT Kharagpur, I delivered a talk. They have a course related to that. Other IITs don't have. There could be another option. There could be more requirement in future to come where engineers need to get involved in the legal profile as such. It's not only on the IPR part of it. There is also another side on the digital crime part. There could be more requirement to come. So this is my few slides to conclude. Sorry to hold you. This is my experience of developing an underwater robotic competition for students, and the winning team was supposed to be sent to San Diego. I awarded it in 2011 thanks to my director, and the ministry approved it. And this was one of the largest funded. We spent about 12 to 15 lakhs to send these 5 students and 1 teacher. And the selection process was with the national committee involving experts from Navy. And I'm glad to say that today country has got 25 plus AUVs developed by themselves, and they are participating in Singapore. I think in NIOT it's stopped now, they may revive it. And globally, this competition has grown very well. The 2 startups are doing very good job now, and they are also doing underwater survey and other activity. So one more project we have launched. I am part of this IIT alumni group called PALS. They approached me. Similar model we have brought in where we call ACDC, the Aqua Cleanup for the river cleanup campaign. We got 40 plus colleges registered, and we will be working with them and developing that. This is the last but one slide. My association, the Marine Technology Society, we started this in India section. More than about for 35 lakhs worth of scholarship for Indian students. We have 10 student section, 11, 12th one will be opening it shortly. And many of our professors, they got an award from the international level. And I'm very glad that interest shown by the students to work in this direction. We'll be launching a conference in April next year on artificial intelligence for oceans. I do have a small role to play by Computer System of India approached, and I got few articles and that will be published, and also one more book on artificial intelligence with few known contacts. So basically for students to say that message to that I talk to many things. It's an opportunity I got, I utilize that. You may get many other opportunity. The education or the platform what teachers have provided you is a basic, but you can always find a way to get connecting people, like IEEE talks about that. I was also in IEEE, I'm also in that. Get connected to the technical society, get connected to the meeting, the people, and involve. Compared to our days, there are much more technology easily available to you. Use that in a positive way. And the world and the country needs your talent for sustainability and climate change, the challenges what we are going to face. Because the UN Secretary General, when he visited India on G20 meeting, clearly said that we are none of the countries meeting 1.5 degree. It's exceeding 2 degree. So we are going to face by 2100 or much earlier also. But the technology is the only way to find solution to face, and the society needs support from engineers like us to contribute to that. With that, I thank once again for all of you and sparing your time to listening my talk, and it was a wonderful evening for me. Thank you very much. It's a good day to remember in my life. Thanks a lot. This is to show you, yes, I had an opportunity to visit various UN organizations. Please do apply. There are jobs available there, and at least get an experience. What is that? That will motivate you in your life. Thank you. Any questions? Maybe one or two, if time permits. Sorry, I had to be very fast because of the time constraint. We started late. You can always communicate through me, email or LinkedIn. Approach me. Any other difficulty, any other things you want to know.
So my question, I'm here.
Yeah.
In the front row.
Yeah. Sorry.
Here.
Yeah, sir. Yes, sir.
Can I say that?
Yes, sir.
Okay, so I think the question was on your slide itself. Why this deep water biological creature have a transparent body? That's a question you written, and
yes.
I was thinking what can be the answer.
Sir, you asked a simple question but very complex. Still we have not understood. You would be surprised to know that close to this underwater volcano there are crabs, there are shrimps which has been recorded, but they do not have eyes. They work on a chemiosynthetic process and not photosynthetic. So maybe nature thought that is enough. Even in my own sampling, when I sailed out, we found underwater optical, we call sponge. We analyzed it. It's optical fiber material. It has got an optical property like conventional material. So how the nature is producing, it's all related to marine biotechnology part of it, because the conditions are same, temperature is same. Simple thing like to make a glass blower, he needs heat, whereas underwater it is 10 to 12 degree. How the nature is producing glass tubes. So like what you are telling, transparent, still it is not understood. And there are available in few locations. Sometimes they go to the same site, they may not get it also. Very rare pictures these are all. Thank you, sir.
Thank you very much, sir. It was a wonderful talk. Hi. So I understand that the oceans are also like heat reservoirs, which means that because we now have this global rise of temperature, the oceans are now slowly heating up. Yeah. And from what I've read, I understand that the cooling of the oceans is also going to take a lot of time.
Yeah.
Which is why perhaps you also mentioned that Australia and the other lower hemisphere countries are going to face the brunt for several years to come.
Yeah.
So what kind of challenges, because this heat is not going to be dissipated, it's a large body of water.
Yes.
So what kind of challenges will such countries face, and how can we kind of, is there a technological solution for
Yeah,
bringing
one is I mentioned about the carbon sequestration part of it. Alkalinity experiment they are doing. That one side they are doing an alkalinity experiment, conventional electrochemical principle only to increase the absorption of carbon dioxide. The challenge for us is much more sea level rise and the erosion. We are seeing it. The countries close to us, Maldives is 75 centimeter only the mean sea level. 1 meter sea level rise can submerge. Same like Bangladesh also. So that's another big challenge. The ocean acidification is another. The ocean is getting more acidic. In that way, some of the animals which has got a calcareous carapace towards that, they are not able to survive. So the ocean acidification is another big challenge we are facing. So it's more complex. I can say that it was more balanced. Now we have created an imbalance by this temperature increase and many other aspects. Correct. What you are telling is correct. Thank you. Yes, sir.
Good evening, sir.
Yes.
Yeah, very nice talk. So my question is, I'm a survivor of this tsunami and the earthquake which happened in Japan on March 11, 2011.
Okay.
So although they had a lot of systems, but there were no previous warnings.
Yeah.
It suddenly attacked.
Yeah.
But now from your presentation, I could see that there are some tsunami alert warnings. So
Yeah.
how soon, or like it will give alert before 5 minutes, or can it also give alert before a month or some days in advance, which can help people to relocate and many lives could be saved?
Sorry, sir. Maybe some miscommunication. It is not early warning.
Okay.
After tsunami occurs, this warning is coming. I'll clarify to you. Japan is the one country which is most affected. The word tsunami came from Japan itself. What you mentioned about 2011, April 17th, our system also we recorded that. That's the reason I cannot forget the date. Japan has spent more than 3,000 crores drilling the earth. They got a drill ship which can go on a particular location, they drill it. They wanted to see the geophysical study, why this earthquake is happening in the fault zone. That is leading to tsunami. They couldn't succeed. They are claiming that earthquake few minutes before they were able to do, but nobody can do that. In the case of tsunami, nobody can predict. Nobody can predict. Of course, now very recently I'm talking about thinking about the whole theory itself, there are small changes. The earth can slide apart, which happened in 2004. Subsequently, in one case, we talk about 7.5 Richter scale is the previous statistic showed. We had 8.2 Richter scale, but we did not have tsunami. We gave a warning because earth still moved like this. There's a less amount of water movement which had happened over there. So this earth movement is not known how it is happening. Whatever we are talking, in the case of fault zone is known to us, which is near Nicobar. Once tsunami occurs, the water body starts moving. It moves at a speed of 700 kilometers per hour, equivalent to aircraft speed. By the time it reaches Indian coast, it takes about 2 hours. The warning is coming to you. And warning, what we do is that we have got a predefined scenario with all the things. We provide in the predefined scenario, and the predefined scenario, once it is released by the Ministry of Home Affairs, within half an hour we have to retract it back. By the time this data will come. This is what the tsunami early warning system globally works. Our warning system is for the Indian Ocean, whole region itself we are providing. Not only this, we need to get a data from the bathymetry. It varies, even though ocean is same, depends on the bathymetry, the amount of water coming into the shore is varying. In the case of Japan, why the warning could not be given? Because nobody knows when it will happen. It can happen now. Today, in my earlier office, I used to have the map. Somewhere earthquake is happening, plate is moving. If it is less than 1.52 Richter scale, we don't notice that. More than 7, 7.5 or 5 in the land, we are able to notice that. This is what the earth system. And the thickness of the crust is 40 kilometer in the land, and the ocean is 8 kilometer. Another big challenge for us. So the statistics says that after 2004, 30, 40 years, but nobody can pinpoint and say it cannot happen. It can happen. Earlier one was 1945 of Bombay. 2 people died, nobody noticed that. That is from the Makran region. For you, close to that is Makran region.
Thank you very much, sir.
Thanks. I'm very glad you are showing interest on ocean.
Hello.
Yeah,
Sir,
yes.
it was a very nice talk. So I am a material researcher. So I wanted to know what are the perspective areas to work in material design and material, yeah.
Yeah, the material, lightweight material, high specific strength is one of the important requirement here. Even conventionally, all the offshore structure, steel has not been replaced by any other material. Of course, for other applications, they have replaced. Even you would have noticed that Elon Musk has opted for stainless steel, not on composite for that, for spacecraft. The one which has dived down and got crushed. So what is required is that material development and stringent testing methodology. So that is what people are working on it, and the DNV and other bodies are working towards that. So we need to work. We know very well composites, carbon fiber composites are doing, how to reduce the cost, how to make the product, how, and the 3D prototype printing also has come into the picture now. So how that can help is another way to look at it. Because we have a big issue of corrosion. Bimetallic corrosion is a big issue in underwater when you deploy for a long-term applications. Of course, biofouling is a big issue. I too have a publication and I have a book on biofouling. In our waters, the biofoulants are very normal, because in tropical region about 1,700 species can get attached to that. Their adherence is so hard that if you remove it, you have to chisel it out. So I have a patent on fluorine material. So conventionally now the paint system is changed because of other environmental regulation. So you can think of an alternate material for which can be polyphobic or which will help us in this direction. So polyphoric and polyphoric, hypophoric and hypophoric. So it has to have both. So maybe you can think about biomimic, start looking in a different material development. Even Navy is looking for such an alternate material. I know very well. There are also high strength material they have developed that's more specific for the naval application. The cost component is coming into that. Ships conventionally they are not changing that faster mode. Thank you.
So if there are no questions anymore, then we will conclude the talk here with a great round of applause.
Thank you. Thanks a lot.
So thank you very much, sir, for the enlightening talk. It has been really sort of a resourceful presentation. Many of the things we have learned actually as a part of this presentation. So I would request Dr. Aniruddha Chakrabarty to come onto the stage to felicitate our guest here.
You remove this.
So at the outset, I would like to thank the speaker for his sort of a distinguished talk. I hope some of you have gained some sort of an insight through this talk. I'm really thankful to the speaker as well as you, as well as with the esteemed colleagues who have attended this talk. And thanks to Dean Academics, AD Research, and our chairperson, Dr. Amit Shukla, for this. Thank you so much.